If we step back from uranium itself and look at the entire nuclear system, a more important question begins to emerge. Who actually controls the nuclear power? At first glance, the answer may seem obvious. The countries with uranium resources should have the advantage, but in reality, the situation is far more complex. Because nuclear power is not defined by resources, it is defined by system. To understand this, we need to break down the nuclear fuel cycle. It includes mining, conversion, enrichment, fuel fabrication, and finally reactor design, operation, and maintenance. Each step requires specialized and expertise, infrastructure, and long-term investment. Among all of these stages, enrichment is one of the most critical. Nitro-uranium contains only about 0.7% of U-235. To function in most commercial reactors, this must be increased to around 3% to 5%. This process is not just technically complex, it is also tightly controlled. Only a small number of countries have large-scale enrichment capacity. Russia, the United States, France, and China dominate this space. But even enrichment is only part of the story. A system control begins even more significant when we move to reactor technology and through integration. But even enrichment is only part of the system. The control begins even more significant when we move to reactor technology and through integration. Nuclear reactors are not a standardized commodity. Each design comes with its own few specification, engineering requirements, and the safety protocols. This creates a powerful dynamic. Once a country builds a nuclear power plant based on a specific technology, it often becomes tied to that technology provider for decades. This is what we can call system locked in. Nuclear plant typically operates over 40 to 60 years, and during that time, it requires a continuous fuel supply, maintenance, upgrade, and technical support. Switching to a different system is not simple. It involves regulatory approval, technical compatibility, and significant financial cost, often in the billions of dollars. As a result, nuclear energy is not just infrastructure, it is a long-term relationship. And we can see this clearly in global market. The company like the Rostom from Russia, the EDF from France, the Westinghouse from the United States do not just sell reactors. They offer full life cycle solutions from construction to fuel supply to long-term servicing. This transforms the nuclear projects into multi-decade strategic partnership. And that leads to a deeper insight. In nuclear energy, control is not exercised through ownership of resources. It is exercised through control of the system architecture. From a geopolitical perspective, this has a major implication. Countries are not only choosing an energy source, they are choosing a technological ecosystem. And once that choice is made, it is difficult to reverse. This makes nuclear energy fundamentally different from most other energy systems, oil and gas can be traded globally and switched relatively quickly. Nuclear systems, however, are deeply embodied and path-dependent, which leads us to a key conclusion. In nuclear energy, power doesn't come from resources. It comes from controlling the system that turns those resources into usable energy. This pattern is not unique to nuclear energy. We see it in semiconductor, in aerospace engines, in advanced manufacturing. Resources matter, but system define power. Nuclear power is simply one of the clearest examples of this principle. If nuclear power is structured this way, then the final question becomes inevitable. Is a nuclear energy coming back? And if so, what role will it play in the future energy system? In the next episode, we will explore the return of nuclear energy power.